The Haber process makes ammonia, and we want to make as much ammonia as possible. But the reaction is reversible, which means that as soon as we make some ammonia, some of that ammonia goes back to make nitrogen and hydrogen. We can, however, optimise the conditions to improve our yield, and one way to do that is to change the pressure. To know what's best to do, we need to consider how many moles of gas we have on either side of the reaction. On our reactant side, we have 1 mole of nitrogen gas and 3 moles of hydrogen, so in total we have 4 moles of gas. On the product side, we have 2 moles of ammonia, so in total we have 2 moles of gas. Now, Le Chatelier's principle states that if we change the conditions of an equilibrium, then the equilibrium position will shift to minimise the change. We want it to move in the direction with fewer moles of gas. The reason this can work is that 1 mole of any gas occupies 24 decimeters cubed. So it has the same volume whether it's nitrogen, hydrogen or ammonia. That means then that on this side we will have a bigger volume of gas compared to this side, which has literally half the volume of gas, so it has a lower volume. If we want it to move to the side with lower volume, then we do it at a high pressure. If we want to move it backwards so it goes to the bigger volume, we do it at a low pressure. So, to increase our yield of ammonia, which is what we want to make, to get it to move to the side with the lower moles of gas, we should do the Haber process at a high pressure. This isn't actually done because having high pressure containers is very expensive to make and difficult to maintain. So we do it at a compromise of 200 atmospheres.